So meanwhile, I just wanted to recap the things that we discussed day before yesterday while the people are joining. So we were talking about placement groups the other day. Placement groups are the a mechanism where you can actually place your instances either on the same host or same rack or different racks kind of stuff. It's all about the placing the instance on the underlying hardware. So when you have placement groups configured, it's depending on your requirement basically. If you need high bandwidth and low latency kind of stuff, then you need to go ahead with the cluster placement group. In cluster placement group, what happens is all the instances will be placed onto the same host possibly or on multiple hosts within the same rack. So they will be close to each other. The physical servers will be close to each other so that you can get the high bandwidth benefit. If your application is depending on such kind of stuff, then you have to go ahead for the cluster placement group. And the partition placement group, where you can split your deployment into multiple partitions to a maximum of 7 partitions. Let me mute it. So 7 partitions. Herein, you can actually place your instances across multiple availability zones within the same region. No 2 partitions or no 2 instances will be placed onto same host or same rack. So they will be distributed across your deployment. If you selected North Virginia as the region and you have your complete deployment across multiple availability zones within the region, we have 6 availability zones in North Virginia. So if you want to spread your deployment across multiple availability zones, you can create the partitions and you can place your instances across the region. So you'll be having distributed computing in this scenario. So no 2 partitions will be placed onto same host or same rack. So within the rack, maybe there is a possibility that they can be placed on multiple hosts, but there is no possibility of placing the instances onto same physical server. And the other way around is spread the deployment, spread placement group, wherein actually you can distribute your instances in such a way where a single instance will be placed onto a single rack. So completely segregated deployment to instance to instance completely. So there is a limitation of maximum 7 instances per IG, and you can the same way as partition, you can also spread your deployment across the region basically. And in partition and spread placement group, you can actually mix and match with multiple instance types, whereas in cluster deployment, you have to only select a specific instance, and throughout the deployment, you have to use the same instance type. And this does not applicable in most cases for dedicated instances and dedicated hosts, because dedicated host in dedicated instance, you will be allocated with a hardware. So if you have multiple physical dedicated hosts, then you have a chance of placing them onto different physical servers by yourself. So that's how the placement groups works actually. And the other options that we have left in the EC2 are we also discussed about volumes, snapshots, lifecycle manager, etc. And we discussed about security groups, elastic IPs, placement groups. Now we need to discuss about key pairs, network interfaces. So this is a small thing basically. So a key pair is a combination of private and public thumbprints. So Amazon actually saves the public key on their side, and it gives you a private key pair for you. You have to download the key pair while creating the instance. If you don't have either of them, either if you don't have the private key, or if you have deleted the public key by selecting the key here, what happens is the combination mismatches and you will not be able to log into your virtual machine, your instance at all. So you have to keep them stored somewhere. Anyway, public key will be maintained by the Amazon itself, and when you actually create an instance, you will download the private key, respective private key that belongs to that matches with the public key. So you have to keep it safe. The private key, you have to keep it with you, and it should be there for the connectivity. And that particular key only useful when you first log into the instance. So to get the Windows randomly generated Windows password, you have to use the private key. So if you don't have the key, for example, in this case, if I don't have AWS Session spam, there is no possibility that I can log into the instance. So you have to make sure you save all these keys in a secured place so that you can actually generate your passwords. So the other way around, to not depending on this keys thing, what you need to do is first time when you first log into the instance, take the randomly generated password and log into the instance, change your password immediately to the standard that your company follows, so that there will be no dependency on the key again and again. If you lost the key also, you can log in with the standard password that you have changed. So that is the best practice. So for the Linux instances, the key should be must. There is no other way around, because it's a different story with the Linux instances when you log into the machines. For Windows instances, we'll be using MSDSE or RDP as a protocol, but for the Linux instances, it's called as SSH. So when you connect to the EC2 Linux instance, the private key must be there, and there is a standard user account associated with each and every Linux instance. Basically, in Windows it's called as administrator, but in the Linux world, in the Amazon, it called as EC2 user, EC2-user. So when you log into a Linux machine, what you need to do is you need to open your PuTTY session, and if you have, for example, think this like a Linux instance, take the IP address and open a PuTTY session saying that EC2-user@IP address. And to proceed with the authentication, additional step is there. Here in the SSH tab and the authentication options, you need to provide your private key. So you need to browse to your private keys, and from which you need to select the respective private key that is associated with the instance and open it. Just this key will be used as the password to log into the Linux instance. There is no randomly generated passwords for the Linux instances. It's just straightforward. You have to have the key with you all the time, and the user account is EC2-user. This is a standard account for Linux boxes, basically. So once you log into the machine, when you pass this key and log in with this user account, it will never prompt you for the password. It's straightforward, logs into the machine, and then you can switch to the root user. Let me create a Linux instance real quick in the background, so that at the end of the session I can show you how these things actually works. So let me take a Linux instance possibly, and I'll go ahead with T2 micro, one instance in the public subnet, and public subnet 1. It's the same options for this, and let's move on to the next storage. Default 10 GB, that's fine. And security group, in here we need to actually add the SSH also. This particular security group is only for Windows, where we only allowed RDP traffic and HTTP traffic. So for the Linux machine to be connected, it has the SSH port to be opened. So let's open the SSH port, and I'll do one thing. I'll create a new security group for the Linux boxes, and probably I'll go ahead and allow all the traffic, because I just wanted to avoid the communication issues, if any. So I'm going to launch this instance. It will be launched in the background. So let's have the same, or maybe I have the other one also. Let me show you with that. So I'm just launching it, and let's come back to this once the instance is launched, and how to connect to the Linux instance I'll show you. So moving on, the network interfaces is the next option that we have here. So network interfaces is like your Ethernet card. So as we saw yesterday, as I mentioned in the earlier sessions, each and every component will be coming from the different layers, like storage is coming from somewhere else, network is coming from somewhere else. So when we created our instances, the volumes are also getting attached to the virtual machine. So if you go to the volume section where you can see all the disk files associated with the machines. In the same way, network interfaces also are getting created as an external thing, component, where you can actually attach or detach whatever you wanted to do. It's up to you. In this case, it is in use because we are powering on the machine, and this particular machine is allocated with a public IP of this thing. So network interfaces is like this particular component will be useful. It's a very useful thing when you use endpoint services on AWS. There is a concept called endpoint services, and also VPC transit gateway. So wherein you have to create multiple network interfaces which does not belong to any of the instances. They will be sitting as independent entities for enabling access to different VPCs in other regions, basically. So that's all in the VPC peering concept. When we come back to the networking stuff, we'll discuss transit gateways, endpoint services, and VPC peering, etc. So in those sessions, we will be having more detail about these network interfaces. So if you can see, we have 3 network interfaces created already, and 2 belongs to Windows instances. The other one that we just created is belonging to the Linux instance, basically. So if you want to attach multiple network interfaces to a specific instance, for example, our Windows instances only have single network interface at the moment. But if you want to attach another network interface, you can go ahead and create a network interface here, which subnet you wanted to place the Ethernet card in, and then automatically a network adapter will be created and attached to the instance that you want to connect it to. So that's how we can actually go ahead and create the network interfaces. And again, like the network interfaces concept will be more meaningful when we go to the transit gateway, private link, and the other stuff that is related to endpoint services when we come back to the network stuff. But for the EC2 part, it's like if you want to add additional resources, additional network cards to the existing instances, you can go ahead and do that, and you can allocate multiple instances, multiple IP addresses, so that machines will be communicating with multiple subnets, kind of stuff. Most of the scenarios won't require multiple interfaces to be attached. But if we have a Windows instance or Linux instance which is running with multiple services, like the same server is hosting HTTP service and the same one is hosting FTP also. In such cases, you can actually dedicate a network adapter for the specific service, and performance and throughput will be increased. So that's how the network interfaces are used in the EC2 point of view. But there is a lot coming up for the network interfaces when we go back to the VPC stuff. So moving on, the other concept that is very important in the EC2 is load balancers. So there are 2 concepts here: target groups and load balancers. So today I wanted to go ahead and discuss more about these load balancers and target groups as well. So what is a load balancer? Basically, a load balancer is nothing but which actually balances the load between multiple similar instances. So for example, if you have a web service or a website being published over the internet, typically it will be hosted by number of instances in the background. For example, if you take Google website, that particular Google page being served by thousands of servers in the background. Those servers will be identical. All of them will be installed with the same operating system. All of them will be installed with Apache or iOS, and the same configuration will be maintained across the fleet. So in such case, if we don't have load balancer concept at all, every machine will be acting as individual entity, and it's difficult for us to actually go and connect to the respective instance directly, because there is no the manager kind of thing to actually route or request to the specific instance. Wherein balancer comes into the picture, load balancer acts as a gateway or a manager kind of thing, so which actually identifies the background instances which are serving the purpose or website, and based on the load. So for example, we have 10 instances serving some website in the background, and we place them behind a load balancer. So load balancer will be published as the URL for the website, wherein it takes the request and forward the request to the background instances. So first request will be forwarded to the first instance, and so on. 10th request will be forwarded to the 10th instance. Then again 11th will be come to first. In the same way, it will move on sequentially. It will actually take the request and forward them to the instances in the background. So in any point of time, the load will be balanced across the 10 instances. The web request will be coming to the web instances, right? So all the load will be maintained across the fleet simultaneously. So that's how the load balancers are useful basically. Load balancers can be used as internet facing or intranet facing. Intranet, I mean within the intranet also you can use the load balancers basically. And if you plan to publish it as a internet facing load balancer, then the public IP associated with the load balancer will be the IP address for your or DNS name for your website. So the request will be forwarded to the respective instances. So let me go back to the slides and show you how the load balancers are available in AWS. There are 3 types of load balancers available. One is classic or ELB, elastic load balancer, and the other one is application load balancer, and the other one is network load balancer. So classic was the load balancer service provided in the early days. So it's getting deprecated very soon because there is no real intelligence involved in the load balancer thing, because it actually it has a basic functionality of taking the request from the users and forwarding it to the background instances. It cannot decide whether that particular request is bound to a specific instance, something like that, or it cannot take a decision at all when it is forwarding the request. The only thing that can do is it actually balances the load automatically. That's the only thing that it can take care of. But they have come up with 2 more load balancer types, which are called as network load balancer and application load balancer. These are highly intelligent when you compare it to the classic load balancer. So with the classic load balancer, we cannot customize the routing options. Like I just wanted to route my request based on the operating system, or I just wanted to route my request based on the port, network port that is being used. So which is not possible with the classic load balancer. Basically, it has a very limited options. Just straightforward, we need to create it and attach the instances so that it will take care of the load balancing stuff. But when it comes to application or network load balancer, there are a lot of customizations available. I mean, when you take network load balancer, if you already have an idea of ISO layers, TCP/IP layers, there are 7 layers, right? Out of those layers, this particular network load balancer stays at the layer 4, and application load balancer will be stays at the top layer, that is layer 7. So these 2 load balancers having their specific configurations. So one is used for the port based routing. For example, you have a Linux machine and you have a Windows machine, and you want to balance the load between these 2 instances, which is actually not possible in the real time scenarios. So the basic requirement for load balancers is we should have the same kind of operating system, same kind of configuration on the background instances, so that the configuration will be identical between all the instances which are serving the website. So that is the main requirement in most of the scenarios. But with the network load balancer, if you want to route the traffic to two different services. I mean, Windows is actually hosting website on the IIS, and Linux will be hosting the website on Apache. So you want to host your Linux website Apache and the web Apache. You want to host it at the port 80, that is default for HTTP. And on the Windows instance, you want to host the website at some port 8080, the customized port. So using the network, this network load balancer, you can do the routing. If the request is coming like www.google.com straightforward. So when it comes as a default web address, the browser identifies it is actually trying to connect over the port 80. So because HTTP is the default for any web application, and HTTPS is also default. So port 80 will be the default for all websites. So we can configure our load balancer in such a way it can identify if the request is coming for port 80, then it should go to the Linux boxes. And if the request is coming for some other port, maybe 8080, the end user opens the browser and types in like www.google.com:8080. So which is on customized port. So network load balancer automatically identifies the port number, and it will forward the request to the associated instances, which is Windows in our case, IIS website. So that's how actually network load balancer can take a decision based on the port number to which instance it should be routed to. If it is on the default 80 port, it should go to the Linux instance with the Apache as the web server. And if it is a request on the port 8080, then it should go to the IIS on the Windows server. So this kind of intelligence will be involved with the network load balancer. And in the network load balancer, what happens is when you configure the network load balancer, it actually acts as a manager. So it takes the request and forward the request to the respective instances straight away. It will not actually your request will be straightforwardly sent to the respective instance in the background. So it takes the request and forwards, that's all. But whereas in the case of application load balancer, the request will be stopped at the load balancer level, and it will be modified at the application load balancer, then moved on to the instances. There is some modification involved in the application load balancer, but network load balancer, there is no modification will be involved. The request will, whatever the request has been received, it will be sent over to the instances as is without modifications. So let me show you the diagram so that you will understand a little bit more, and then I come back to the theory part again. So when we create a network load balancer or any kind of load balancer, we create target groups. Target groups are the collection of a group of virtual instances, either Linux or Windows, will be working together to serve a service in the background. So target groups are the key things. Target groups are the containers for the instances. They contain multiple instances in the background. So these target groups will be connected to the load balancers. So load balancer will take a necessary decision and forward the request to the background instances. So let me show you the diagrams real quick. So target group is nothing but it's a group of instances, basically, either Linux or Windows or any other operating system which Amazon supports. So this is a classic load balancer. This is how it looks like in the just a diagram to showcase how the load balancer actually works. So these are the endpoints which are like end users coming from the web. They are requesting for the website. They opened their browser and opened www.something.com. So this request will be forwarded straightforwardly to the load balancer. Why it is going to the load balancer? Why not to the instances directly? Load balancer will be having the public IP and associated DNS record. So whatever website you type in your browser, that name will be assigned to this load balancer, www.google.com or yahoo.com. Whatever the DNS name, that name will be assigned to load balancer, and it will be associated with a public IP automatically. So when a end user opens his browser and types in the web address, DNS resolution happens, and it will go to the load balancer directly. So behind the load balancer is nothing like it will not be serving any of the service. It doesn't have any web server installed. It doesn't have any application installed. It just routes the request. Whatever the request comes from the end user will be forwarded to the instances. That's what it takes care of. There's nothing involved in this. There's no operating system. There is no application installed. Everything will be actually comes from the instances only in the background. So when we create the load balancer, we create target groups, and we attach those target groups to the load balancer. So when a end user actually fires up his browser and opens a website, that website will, that web address will be actually assigned to the load balancer, and you will be hitting the load balancer directly, and that request will be forwarded to the backend instances. So that's how the load balancing stuff actually works. So this is the classic load balancer. It doesn't involve any intelligence at all. It cannot decide whether which port should be routed to which machine or which path should be routed to which machine, kind of stuff. So in this example, I just marked an instance as down. So there are 8 instances from 4 instances from availability zone A and 4 another instances from availability zone B. So all of them are configured with the same operating system, same application, same web server, same configuration. So when end user actually hits from the browser, those requests will be served by these 8 instances. So whatever the first request will be going to this particular instance, and so on, in the respective request will be moved on to the attached to the respective instances basically. So in this case, this particular instance is down. So load balancer actually automatically identify that this instance is down based on some health checks, and it will drop the connections to this machine, this instance. So out of 8, 1 is down, so 7 will be serving the request. So all the requests will be rotated between these 7 instances. So that's how the actual load balancing happens. And also at any point of time, all the load will be balanced across these 7 instances. No single instance will be getting higher load, or no single instance will be getting lower load. So it actually maintained balanced across the fleet. So this is how the classic load balancer looks like. And the other load balancer, it is network load balancer. So the same architecture when it comes to the load balancer options. But if you see here, we are actually creating the target groups in the network load balancer, where in the case of classic, there is no option to create target groups as such. So, but network load balancer, you can actually create your target groups, segregating between the operating system or between the port number that is being utilized from the fleet. So I've created 2 target groups here, a group of instances installed with Linux, and they are actually installed also with the Apache. Website is serving from the port 80 default, which are from East 1A availability zone. And the other fleet is Windows machines. I have customized my port because at any point of time, you cannot conflict between 2 fleets. I cannot use port 80 for Windows because it is already been assigned for the Linux fleet. Linux machines already using port 80. So that is the reason I'm using other port here for the Windows website. So if you want to use the 80 for Windows also, then you have to create another load balancer on side of this particular one. So if you want to use single load balancer and route your requests based on the port, if it is coming for port 80, it will be moved forwarded to the Linux target group. If it is coming for port 8080, then it will be moved on to Windows target group. That's how network load balancer actually can take a decision and forward your request to the respective target group. The other one is application load balancer. So here also the same case, we'll be creating some target groups, but the major difference between network and application load balancer are you can route the request not based on the port as in the network load balancer, but you can route your request based on the URL path. If it is something like www.google.com/sales.html, then that request has to go to the first target group. If the URL contains /marketing.html, then that request has to go to the other target group, which is maybe from the same availability zone or same different availability zones. Here the port doesn't matter. You will be actually creating the website on the port 80 only across the fleet, but the URL is the main thing here. Whatever the URL you specify, like if the URL contains a specific word like sales or marketing, that request has to go to this particular instance pool, or if it is going, if it contains sales, then it has to go to the particular pool. That's how it will be path-based routing, it is called as, whereas network load balancer, it is port-based routing. And also application load balancer, there is an option called host-based routing also. So you can select between Linux or Windows, and depending on that also you can actually route your request to the respective fleets. So we'll see how this load balancer will be configured and what are all options available. So when we configure a load balancer, there is a mandatory requirement of creating the target groups. So target groups again contains multiple instances, and instance health will be monitored by the load balancer itself. So how the health checks will happen? So load balancer keep on sending either ping to the instance or maybe HTTP request to the instance in the background. So that is not visible to us. If any of the instance is not able to communicate over the network, then automatically load balancer take a decision to move that particular instance out of the pool and drops any connection to that particular instance. So all the health checks will be handled at the load balancer level only. So health checks will be associated with the target groups. So let me show you how these things can be configured in the real time, and we'll discuss further while we working on the stuff. So you need to go to the load balancers page, and before that we can actually configure some target groups also. Let's go ahead and create some target groups. We don't have multiple instances here as we have limited resources. We just only have three instances created. So let's utilize them accordingly, and just give me a moment here. This is just to identify which instance I am working with. So all of them are not running. Let me power them on also. Start. Okay, now our machines are getting powered up. So I have a private instance which is anyway not useful to me, probably, or private instance is the one that is useful to me. Public instance is not useful to me because we are placing these instances behind the load balancer, so they didn't need to be assigned with any public IP. Load balancer will be having its own public IP, and those requests will be forwarded automatically. So first we need to go ahead and create a couple of target groups. So let's name it as TG Linux first, as our Linux machine is already running. So target type, which target you want to actually associate this target group with. You want to go ahead with the instance selection, or you want to go ahead with the IP, or you want to go ahead with the Lambda function. So what are the major differences here? So if you want to create your target group with the target type as instance, you can select your instances directly. You can actually attach your instances. So in this page, we'll not be able to select the instances, but once the target group has been created, then we can attach the instances to this particular target group. That's how it can be done. Well, what is the second option? Something wrong. What happened? Okay, so the second option is IP. So why this IP is useful here? Why can't we go ahead and select our instances directly? Why IP option has been placed? So there are, you actually want to take advantage of the load balancer from AWS. which is the highly available service and scalable service. And you don't want your web servers to be running on the AWS. You want to keep them your on-premises data center so that security will be in your hands. So you wanted to maintain the web servers on premises in your own data center, not on the AWS part. In such case, actually you can point to the IP. If you have a VPN connection between AWS cloud and to your on-premises data center, they will be communicating with each other, right? So once you establish the VPN connectivity between your AWS and on-premises, or maybe if you have direct connect connection established between AWS and data center, then you can actually utilize the IP address so that you can mention the IP address of the on-premises server directly. So that's how the IP address is mentioned here. So you can create the load balancer on the AWS side, but you can attach your machines from the on-premises directly. There is no need of creating instances on the AWS if that is your requirement. So you can point your machines from the on-premises and attach them to the target group here. So load balancer will be from AWS and machine from your own data center. Lambda function, it's a PaaS service. So serverless computing it is called as. So this is a new service introduced recently, which is like creating a function, a development function using some Java or something like that, and placing that function in the AWS cloud so that you can actually call it whenever you need. So it's not like a complete web server being hosted or a complete instance getting created here. It's just the function that you can publish over AWS and you can utilize whenever you require. So there, in such cases, you can use Lambda function. So our course actually doesn't have the what do you call? I'm not going to discuss more about SaaS here. So it's all about IaaS we are discussing. So I'll just leave it as it is, and we'll go ahead and choose between instance or IP. So I'm going to go ahead and choose instance because I have a couple of instances created already. And protocol. So which protocol you wanted to use this target group for? So if you're hosting a HTTP web service, then you can choose between any of them. So application load balancer will be only having these two protocols as the options. For the network load balancer, these are the options available. So if you're going to create an application load balancer and your target group should be created with either of these protocols. So that's how it can be. And what is the port number that you want to utilize for this web service? So it's better to actually create this target group while we are creating the load balancer directly instead of creating prior to the creation of a load balancer. So these are the health checks available, and healthy threshold every 5 minutes it will actually go ahead and try to access the URL that you mentioned on the instances. If the response is not coming in 5 attempts, that instance will be marked as unhealthy host. Within 2 attempts, it will marked as unhealthy host, and it will be moved out of the pool. So the request will not be forwarded to that particular instance. Timeout 5 seconds, which is like if the response is not coming from the instance, timeout will be you can configure as many as seconds you want. So for our testing purposes, it's better to have 5 seconds as the because we want to see the response as soon as possible. And interval is how frequently the timeout or healthy threshold should be verified. That is 30 seconds. Success codes 200 is the default one, which is like success for the success HTTP successful request. 200 is the code. If it is 404, something like 404, we will see 404 not found, something like that. So website is not available. In such case, 404 will be utilized. I mean, if it is not serving the purpose, or if you want to use some other than, I mean, the default is 200 for the success. If a web server is responding, the code will be 200. Other than 200, everything is unsuccessful code, some error, 404 not found or something like that. So we'll leave it as it is. Let me go back and create the load balancer first. In the wizard, you can see the target group creation also, where we'll discuss. So load balancers type, 3 load balancers are available, 3 types of load balancer: classic load balancer, network load balancer, and application load balancer. As you can see, a network load balancer can handle TCP, TLS, and UDP traffic. Application load balancer can handle HTTP and HTTPS requests. But the previous one, it actually can handle all the type of traffics, but because there is no intelligence involved. So let's see the options associated with the classic load balancer first, and load balancer name, then move on to the other load balancer. CLB01, and the VPC that I wanted to place it is on North Virginia. And if you want to create an internal load balancer which is not facing to the internet, you don't want to use it for your internet, so you want to use it for your intranet. When we use the internal load balancer, so every web application will be having their own DB instances, database instances in the background, right? So if your web servers are getting serving some website, then there is a mandatory requirement of publishing them over the internet, otherwise the web service will not be utilized. So we'll place all our web services in the public subnet, and we'll assign a public IP to the service so that people can utilize the web service. So as you have multiple web servers, you will also be having multiple database instances in the background. So all these web servers has to communicate with the database instances to get the data from the database and present it to the end user through the web portal. So you will be creating 2 subnets, public subnet, one public subnet and private subnet. You will place all your web servers into the public subnet and place your database servers into the private subnet, so that they cannot be exposed over the internet at all. But you have multiple DB instances, so you can place a load balancer in front of them also, and give that load balancer IP to the web server so that they can communicate. So in the backend also, you can actually balance the load on the database layer. So in such cases, you can actually utilize the internal load balancer. So in our image, what happens is, when you select this particular option, or maybe this one, another fleet of instances will be placed below, right below, and there will be one more load balancer will be created here. So all the instances which are talking to the database instances, they cannot connect to the database instances directly, and they can use the internal load balancer to route the request to. If you want to create an internal load balancer, that's how it can be useful. So if you tick this, it will be internal load balancer. Otherwise, it will be a public by default. So what service are you going to publish using this particular load balancer? Are you going to use HTTP or HTTPS or TCP or SSL? So that's all you can actually select. There is no other options available for this. So you just need to specify the default protocol being used and the default port being used here, so that all the requests will be routed over to the respective instances in the background. And which subnet this particular load balancer you want to put in. So remember one thing: if it is an internal load balancer, we need to put it in the private subnet. If it is an internet load balancer, which is publicly facing a load balancer, then you need to select your public subnet to place this instance to, because it has to be associated with a public IP. It's a mandatory requirement, and public subnets will be having that functionality of assigning public IPs to the resources in the public subnets. That's how we configure public subnets in the first place, right? So when you place your load balancer in the public subnet, it will be assigned with the public IP. Otherwise, there is no use of creating the. So otherwise, it will become private load balancer. It will be internal load balancer. So why I have selected 2 subnets here? Again, I wanted to span my load balancer across multiple availability zones, so that if one availability zone goes down entirely, then other availability zone will be available, and the instances in the other availability zone can serve the purpose for me. So that's why I selected two subnets from two different availability zones. By default, load balancers are at the VPC level, not at the VPC level in the sense region level. They are not designed to be working at the availability zone level. They can span across multiple availability zones like VPC. So in other words, it's a regional level component. So you can span across multiple availability zones. So that's why I've selected two subnets here, and we can actually attach a security group here like we do for the instances also. So if you want to only allow HTTP traffic, so it acts as a firewall again. So at the load balancer level also, you can actually attach a security group for the classic load balancer, which is not the case with the network load balancer. Again, application load balancer will be having security groups, but here there is no intelligence involved, right? So all the requests will be straightly forwarded to the instances in the background. So if if it is getting forwarded into instances, then it should have the security at the instance level. So this particular security group will be applied to the instances in the background, even though if we are creating during the load balancer creation, these rules will be applicable at the instance level only. Whatever the rules we allow, all the rules will be applicable to the instances only. So improve your load balance security. Load balance is not using any secure listener. So if you have any SSL certification or HTTPS protocol, it's just simple that we use the default AET, which doesn't provide any security. Anyone can actually hack into the web server. That is the reason people are using. Most of the websites are hosted at the HTTPS. So even though Amazon is also hosting their website at the HTTPS protocol, so that all the communication will be encrypted by default. So we are using port 80 here. That's the reason it's showing this error. So port 80 is sufficient for us for the demo because we don't have any SSL certificates or such purchased right now. So I'm moving on with health checks. So there is no target groups associated with the classic load balancer, as I mentioned. We are not creating any target groups here. We are just forwarding all the requests to the this thing, I believe. So health checks. So on which protocol you want to actually do the ping? You want to hit the instances on the port 80 frequently within a certain period of time. So then you can choose between different protocols, as you can see here. So if it is ping, the load balancer will ping all the instances in the background on the port 80. So if the request, if the reply comes from the instance, then it will be marked as healthy instance. If the response is not coming from the instance, then it will be marked as unhealthy and taken out of the pool. All the requests will be dropped for that particular instance. So if it is something, if the protocol you wanted to use is HTTP, it will try to hit the URL that is configured. For example, www.google.com/index.html. You have index.html file associated with your web server. So then a load balancer will try to hit this URL every 30 seconds. And if it gets a response code of 200, which is success, then it marks as healthy or otherwise unhealthy. So health check is nothing but continuously hitting the instances, either through ping or HTTP request. So if the response comes from the instance, then it will be marked as healthy. If it is not coming, then it marked as unhealthy. So that's how the health checks are useful. For all the load balancers, health checks are mandatory. So without health checks, you cannot actually determine whether the backend instance is running or not. So that's how the actual this thing is configured. And here, see, there is no concept of target groups here. For the network load balancer or application load balancer, you can see target group page in this section basically. But here they are giving the instances directly. There is no target group associated with it. So you can select the instances, whatever instances are associated with the service, and you can actually allow the instances to serve the request for you. So enable cross zone load balancing, which is if you have your load balance span across multiple availability zones. And what happens in the background is Amazon actually creates two load balances by default. I mean, if you how many number of availability zones you select, you for the load balances, those many load balances will be virtually created in the background. But for us to see from the portal, it is one load balancer always. For the end user, it will be single load balancer. But in the background, Amazon actually creates multiple load balancers, all of them working together and serving our purpose. So enable cross-zone load balancing is nothing but if something goes wrong with one of the load balancer in one of the availability zone, the requests coming from end user should forward it to the other load balancer so that they can the instances in the that specific availability zone can taken care. So in this case, what happens is if something goes wrong with the load balancer in this availability zone, and this availability zone, everything is connecting well. So when you enable cross-zone load balancing, the request coming from end user, and actually they are assigned to this particular availability zone. And so for some reason, that load balancer in this, let me show real quick. So this is how it is actually maintained in the background. So for us to see from the portal, it will single load balancer. But in the background, multiple load balancers will be created as a single entity. It will be published for us. So for some reason, this availability, this particular load balancer has gone down, and we want our request to not to be dropped. Right. So what happens is whatever the requests that are coming to this load balancer will automatically migrate it to these instances. I mean, this is down. I'm sorry. So in this case, this is down completely. We are not having any request being served by this load balancer. All the requests are coming to this particular load balancer only, because we already the load balancer has been down in this region. So whatever the requests that are being sent by the end users, all the requests are coming to the first load balancer in the availability zone A, and by default it actually routes the request to instances in this particular availability zone. But when we enable the cross-zone load balancing, what happens is it can actually forward your request to the instances in other availability zone also. So it can take care of that in the background. So even though the load balancer in the second availability zone is down, first one can actually forward your request to the instances in the other availability zone also. That's how it is designed. So cross-zone availability zone is nothing but you can actually provide high availability at the load balancer level, and if one of the load balancer goes down, then the other load balancer can forward your request to the instances in the other availability zone. That's how it is taken care. So that's the cross-zone load balancing is. If you want to enable, you can enable, otherwise disable. Enable connection draining. What does it mean? Connection draining is default 300. So I have multiple instances attached to the load balancer, like in this figure. So I have multiple instances. I have registered the load balancer with multiple instances. So for some reason, I've decided to remove a couple of instances out of the load balancer. I just want, initially I put 4 instances, but now I wanted to stick with 2 only. So I want to remove 2 out of 4. So connection draining, what happens is by default the value is 300. So prior to the deletion of these instances from the load balancer, those instances, the removed instances, which are the instances which are getting removed, they're actually responding to the end user request prior to the deletion. Until the point that we try to remove instances from the group, they are actually serving some request from the end users. So those requests should not drop immediately. Those requests has to retain for some time. So at least until the request is completed. Otherwise, end user will see some errors on their browser. So that's what I don't want to happen. I wanted to wait the instances until the connection has been completed, the request has been completed. So connection draining, that is the purpose of connection draining actually. It will wait for another 5 minutes after the deletion of the instances, and it will complete all the ongoing requests on the instances which are getting deleted, and then it will remove the instances from the pool. So if you enable this option, once you remove the instance, it will wait for the 5 minutes in total to handle the ongoing requests. Then once 5 minutes duration is completed, within the 5 minutes, it will not accept any other additional new requests. So whatever the requests that are previously there will be served completely and finished successfully. Then it will mark for the deletion from the pool basically. So connection draining is to wait for some time to handle the ongoing requests before we remove the instance from the load balancer. So that is the connection draining means. And next thing is key tags. This is for organization. So it's up to you, like whatever you wanted to place in here to filter out the resources. Key tag values, tags are associated with every resource throughout the AWS. Whenever you create any resource, like an instance, like a volume, snapshot, every resource will be associated with the tags. So it's just to organize your resources within the deployment. And review and create. So once you click on create, a load balancer will be created, and associated instances will be serving your purpose in the background. So once you click on create, it gets created automatically. And so as we placed our load balancer into the public subnet, this particular instance will associated with a public IP. Once the provisioning is completed, then a public IP will be associated with this, and there is also a DNS record associated with this by default. So if you hit this URL from your browser, and the backend instance has some web service associated with, where you can actually see the website. So we just associated this load balancer with one of the instance, which is Linux instance. So it's just added to the load balancer, and it's still going on with the configuration. Instance registration is in still progress. So it is our Linux instance, and we haven't configured it yet with any web server, so we don't see anything at all at this point of time. So after some time, like after a few seconds or minutes, this particular item will become healthy. Currently the registration of the instance is in progress. So instance is getting associated with the load balancer. Once it is done, and once it becomes healthy, then if you go back to your load balancer URL, if you take the URL and hit it from the browser, if the instance has any web server installed already, you can see the web page here. So that's how actually you can actually create your load balancer and associate your instances with it. So you can add more instances if you want. If you want to remove the instance, you can remove it from here. It's up to you completely. So once it is completed, then we can see something comes up from the web server. So what I'll do is I'll stop here for today, and I'll recap everything that we discussed about the classic load balancer, sorry. And I'll try to do one thing. So I'll configure the web service on this Linux instance using the Apache, some web page, a default web page, and let's see how it is actually how it can be accessible from the web browser from our end user end, so that you can actually understand what's happening with the load balancer and the respective instances. And also we'll discuss more about network load balancer, application load balancer, how they can actually serve our purpose. So for the network load balancer and application load balancer, we must have multiple instances to be created, because port-based routing, path-based routing to be, if we want to showcase the demo, then we have to have multiple instances. So I'll get the environment ready before our next session started, and I'll proceed with the network load balancer and the application load balancer also. So I'll stop it here for today. I hope this is informative for everyone. I'll upload this video once our session is finished. Thank you so much for your time, guys. So I'll continue the session on Monday again. Thank you so much for your time.